Hi students, Professor Nugent here. In this video we are going to discuss model specification, how to decide what variables to include in a regression. The most important point is to identify the variable of interest. You're looking at a relationship between the student-to-teacher ratio and test scores. The variable of interest is the student-to-teacher ratio. If you're interested in the relationship between credit and interest rates, there may be an interest rate that is of interest, and that would be your variable of interest. Then you need to think of the omitted causal effects that could result in omitted variable bias. There are two things that you can do. You can include the omitted causal effects if you can measure them, if you can get data on the omitted causal effects. If you cannot, then include variables that are correlated with the omitted causal effects that serve as control variables, that serve as proxies for the omitted causal effects. The control variables are effective if the conditional mean independence assumption plausibly holds. That is, if U is uncorrelated with the student-to-teacher ratio once the control variables are included. This regression will result in a base or benchmark model, a model with the variable of interest and any important correlated causal effects or control variables. I want to emphasize that if we have control variables in the regression, we need the conditional mean assumption to hold. And the conditional mean assumption means that the variable of interest is no longer correlated with the factors contained in the OLS residual, but the control variables are correlated with the factors contained in the OLS residual, and that is what makes the control variables good control variables, is that they are correlated with the omitted stuff in the OLS residual. We also want to specify a range of plausible alternative models which include additional candidate variables. Other things, for example, that may affect test score. We may estimate the base model and the plausible alternative specifications as sensitivity checks, including additional variables that affect the test score. Then we'll ask, does including a candidate variable, an additional variable that affects the test score, change the coefficient on the student-to-teacher ratio? If including other variables in the regression does not significantly, substantially change the coefficient on the student-to-teacher ratio, then you can say that the OLS estimate of the regression of test score and student-to-teacher ratio is robust. You've found a robust causal effect. You also want to look at whether the candidate variable is statistically significant. Our judgment is informed by theory and by principles of econometrics. There is no mechanical recipe here, and it's important not to try to maximize R squared. There are many pitfalls associated with doing so. Let's think about this. It is easy to fall into the trap of maximizing the R squared and adjusted R squared. But this loses sight of our real objective in an unbiased estimator of the class size effect. A high R squared or adjusted R squared means that the regressors explain or are correlated with the variation in Y, depending on your identification. A high R squared or adjusted R squared does not mean that you have eliminated omitted variable bias. It is very possible that you have included regressors that explain a lot of variation in Y, but those regressors may still be correlated with the omitted stuff. Furthermore, a high R squared does not mean that you have an unbiased estimator of a causal effect. It is possible, as we just discussed, that you may have omitted variable bias or other sources of bias, such as classical measurement error. A higher squared does not mean that the included variables are statistically significant. This must be determined using hypothesis tests, whether they are individual tests on coefficient or joint tests using the F statistic. There are other ways that are more advanced in terms of choosing regression models, and I'm happy to discuss these during office hours. But it is important to think about your R-squared as just one of the statistics that describe measures of fit, but hypothesis tests, joint hypothesis tests, and theory and judgment should inform which variables you choose to include in your regression.